Welcome to our podcast, where we cover unique and interesting stories for you. In this episode, we will discuss how water may have formed just 100 to 200 million years after the Big Bang. Water is believed to have emerged during Earth's formative stages, as its origin dates back to the birth of our solar system. However, authors of a recent paper suggest that water may have first formed 100-200 million years after the Big Bang. In a modeling paper published in Nature Astronomy, the authors suggest that the formation of water may have occurred in the universe earlier than previously thought. Water is crucial for all kinds of flora and fauna present on Earth. It has been an integral part of our planet's history as it has shaped Earth's evolution, supporting life in all its forms. Researchers said in the latest paper that water can form in low metallicity gas, like that present at high redshifts. It was believed that water came during the formative stages of our planet, with volcanic activity and meteorite impacts, releasing massive amounts of water vapor into the atmosphere. This water vapor eventually condensed, forming the oceans, lakes, rivers, and other water bodies that we see today. Scientists had earlier proposed two main theories to describe where this water came from in the first place. They said either Earth was born with water already present, or water-rich asteroids and comets collided with our planet, bringing water along with them. The water molecule is composed of two hydrogen atoms bonded to a single oxygen atom, a structure that's essential for life. This molecular arrangement is thought to have formed during the first 3 minutes after the Big Bang, when the universe was still in its early stages. Both elements are known to have formed in different ways. For example, scientists have explained that lighter chemical elements such as hydrogen, helium, and lithium were forged in the Big Bang. However, heavier elements such as oxygen are the result of nuclear reactions within stars or supernova explosions. To carry out the study, researcher Daniel Whelan and his colleagues utilized computer models of two supernovae, the first for a star 13 times the mass of the Sun, and the second for a star 200 times the mass of the Sun. The scientists then analyzed the products of these explosions and found that 0.051 and 55 solar masses of oxygen were created in the first and second simulations, respectively. It happened due to the very high temperatures and densities reached. The researchers found that water developed in the remaining dense clusters of material as this gaseous oxygen cooled and combined with the surrounding hydrogen left behind by the supernovae. The second generation of stars and planets was probably formed in these clusters. The primary sites of water production in these remnants are dense molecular cloud cores, which in some cases were enriched with primordial water to mass fractions that were only a factor of a few below those in the solar system today. These dense, dusty cores are also probable candidates for protoplanetary disk formation, the abstract of the paper read. Besides revealing that a primary ingredient for life was already in place in the universe, 100-200 Maya, after the Big Bang, our simulations show that water was probably a key constituent of the first galaxies, the study further mentioned. Thanks for tuning in. If you enjoyed this episode, be sure to subscribe and share your thoughts in the comments. Stay connected for more exciting discussions and updates in our next podcast.